Hello my lovely viewers, welcome again to Mathematics and I. It's the presenter Jefferson, and today on the board we shall be learning how to simplify surd. And we have three questions that we shall be using in explaining simplification of surd. Remember in our last video we talked about simplification of surd also, and we said that simplification of surd begins from root 8. And then we said for us to be able to simplify a given number in surd form, we have to think of two numbers that are, one is rational and the other is irrational. And we said that the best way for us to think of these two numbers is using the LCM method. So if for instance we have something like this, simplify root 50. It means using the LCM method for 50, the first number that are going to 50 is 2. Now 2 into 50 gives us 25. Now 5 into 25 gives us 5. And 5 into 5 gives us 1. Now when you are done with the LCM, the next thing you do is that you circle out two numbers that are the same. And the two numbers the same here is 5. So 5 times 5 gives us 25. So the two numbers I'm using to replace 50 is 25 times 2. 25 is rational and 2 is irrational. So here we come, root 25 times 2. Now, the square root of 25 gives us 5. And what do we have inside here? Root 2. Now, without wasting time, we shall be solving the three questions that we have on the board. Okay. Now, question number 1 says, simplify root 7 plus root 3 all raised to the power of 2. Now, let's go back to the laws of indices. The laws of indices says when power 2 is here, it means the base appears 2 times. Now, when we expand this question, we have this root 7 plus root 3 and another root 7 plus root 3. This is because of the square we have here. Now, after this, we are going to open the bracket. And how do we open the bracket? The first number here multiplies everything inside the second bracket, and the second number also multiplies everything inside the second bracket. And when we do this, we are going to have this. Now, root 7 times root 7 gives us root 49 plus root 7 times root 3 gives us root 21. Now, root 7 has multiplied everything in the second bracket. Then the next that will multiply is root 3. Now, the sign here is plus. Now, root 3 times root 7 also gives us root 21. Plus times plus gives us plus. And root 3 times root 3 gives us root 9. Okay, now we all know that the square root of 49 is 7. But we don't have the square root of 21. And also, we can't simplify 21. Or even if it is greater than 8. Why did I say we can't simplify 21? It is because when we look for the LCM of 21, there are no two numbers that are the same. Just watch. LCM of 21 is just 21. So you see, they don't have two numbers that we can circle out. So 21 is still 21. But something happens here. We have root 21, we have root 21. The roots are the same. So what does that mean? I can add them together. Now note, it is only when the roots are the same that they can be added or subtracted. When the roots are different, they can't be added. They can only be multiplied when the roots are different. So if I have 1 root 21 plus another 1 root 21, you are not adding the 21, rather you are adding the numbers at the back. Now 1 plus 1 gives us 2 root 21. Okay, plus the square root of 9 gives us 3. Now, there is no way I can add 7 to 2 root 21 because 2 is carrying the root of 21 and 7 is not, so they can't be added. But I can add 7 to 3 because why? Both are not carrying what? Root. So 7 plus 3 gives us 10, then plus 2 root 21. This becomes the answer to this question. Alright, that question belongs to question number 1. And so we shall be moving forward to question number 2. Okay, now question number 2 says 3 minus 2 root 2 over 3 plus 2 root 2. Now the first thing you ask yourself is, what is wrong with this question? Why should we simplify this question? Now see, the problem with this question is at the denominator. The expressions at the down of the fraction. Now what is the problem? It is this root. The root sign. Now you are not supposed to have a root sign at the denominator. Now it could be at the numerator, there is no problem. But when the root sign becomes, is at the denominator, then you have to do something. And what do you have to do? You have to rationalize. Now rationalization is a process whereby you eliminate or remove the root sign from the denominator, not from the numerator. And now how can we rationalize this? Now you multiply both the numerator and the denominator by exactly what we have at the denominator. But the sign changes. If this is positive, it becomes negative, and if it is negative, it becomes positive. And so we're going to have this times 3, instead of positive, it becomes minus 2 root 2 over 3 minus 2 root 2. Okay, when we do this, we are going to multiply, but we have times here. Now 3 again multiplies the 2 of them, and 3 root 2 also multiplies everything there. So now 3 times 3, 9, minus 3 times 2, 6 root 2. 3 cannot multiply this 2, because why? This 2 is inside the roots. So 3 can only multiply the number outside, which is 2. Now 3 has multiplied, so what's going to multiply now? 2 root 2. Now what sign is here? Minus. Now 2 times 3 also gives us 6 root 2. Minus times minus gives us plus. 2 times 2 gives us 4. And 2 times 2 also gives us 4. Okay, all over. Now we apply difference of 2 squares in solving the denominator. You will notice that the denominator has nearly the same thing. This is 3, this is 3, this is 2 root 2, this is 2 root 2. The only difference is that the signs are what? Different. Here is positive and here is negative. And whenever you have something like that, it is called difference of 2 squares. Now how do you solve the denominator? It is shorter. The first only multiply the first, and the last multiply the last. Simple. So now 3 multiplied 3 gives us 9. Plus times minus gives us minus. 2 multiplied 2 gives us 4. 2 multiplied 2 gives us 4. Now you see, it is shorter because I don't have to use this first to multiply everything, and I don't have to use the second to also multiply everything. But why is this possible? Because they are difference of 2 squared. Okay, now let's proceed with math. Now here becomes 9. Now I have root 2, I have root 2. They are the same. The roots are the same, so I can work with both of them. Now minus 6 is minus 12. Then I pick one of the root 2, minus 12 root 2. It's like you are owing someone 6 root 2, and then you are owing again 6 root 2. How many root 2 are you owing? 12 root 2. Now plus 4, the square root of 4 gives us 2. All over, here becomes 9 minus 4. Also, the square root of 4 gives us 2. Now let us continue. It becomes 9 minus 12 root 2 plus 8. Now how did I get 8? 4 times 2 gives us 8 over 9 also minus 8. So automatically we have this. Now there is no way I can subtract 12 root 2 from 9 because 9 is not carrying root 2. But I can do 9 plus 8, and that will give us 17 minus 12 root 2 over 9 minus 8 gives us 1. And you know that the answer becomes 17 minus 12 root 2. Because why? Anything divided by 1 will give you what? What is dividing it. And this becomes the what? The answer to this question. Now class, when you follow this step by step accordingly, I bet you are going to get the right answer. Okay, without wasting time, let's go to the last question for today, which is question number 3. Now, question number 3 says, root 32 over 2 minus root 18 plus root 2. Now, like I said, whenever any question on surd is given to you, the first thing you have to do is to look at the numbers inside the roots, if they are 8 or greater than 8. Now, the number here is 32. Whoa, far more bigger than 8. So we have to look for the two numbers that we can break 32 too. Now, himself, we can do that using the LCM method. Okay, now 2 into 32 gives us 16. 2 into 16 gives us 8. 2 into 8 gives us 4. 2 into 4 gives us 2. And 2 into 2 gives us 1. Wow, there are a lot of 2's that are the same. But what did I say? Circle out 2 of them, group them. And the first 2 is this, the second 2 is this. Now, what do you do next? Multiply all the numbers that we have circled. Now, 2 times 2 gives you 4, 4 times 2 gives you 8, and 8 times 2 gives you 16. So, the two numbers I am using 16 times 2. So, here becomes root 16 times 2 over 2 minus. Also, we are going to solve for the LCM of 18. Now, 2 into 18 gives us 9. 3 into 9, 3. 3 into 3, 1. The two numbers that are the same is 3 and 3. Now, 3 times 3 gives us 9. So, the two numbers I'm using is 9 times 2. So, here becomes root 9 times 2 plus root 2. Now, why did I leave this as root 2? Because why? 2 is not up to 8, so I don't have a problem with it. Okay, the square root of 16 gives us 4 root 2 over 2 minus square root of 9 gives us 3 root 2 plus root 2. Now, we all know that 2 can divide 4, but 2 can never divide 2. Because why? This 2 is inside the root. It's being guided. It's being protected. And so 2 can't just divide it. 2 can only divide this 2 when this 2 also is having a root. It's inside the root. So, I have 2. So 2 here 1, 2 into 4 gives us 2. So what do we have? 2 root 2 minus 3 root 2 plus root 2. Now you see now that all are carrying root 2. So I can work with the whole of them. So the first number here is 2 minus 3. That gives us minus 1. Minus 1 plus 1. That gives us what? 0. Class, there is nothing like 0 root 2. The answer becomes what? 0. So class, this is the end of today's class, and I believe you have been able to understand how you can work problems on simplification of surds. Now, if it's the first time of coming across our channel, please don't forget to subscribe, and also don't forget to like and leave a comment in the comment section. Also follow us on Facebook, Jefferson Hope, and together I bet you we can make mathematics easier for us all. Till we meet again in our next video. Goodbye.